Welcome to this explainer. Okay, so today we're diving into a topic that shows up in literally every single examination series for Cambridge AS and A-Level Mathematics 9709. I'm talking about circular measure. But look, we aren't just going to sit here and crunch numbers today. No, we're going to approach this entire topic like an archaeological dig. We're going to uncover the precise strategies, the hidden clues within the questions, and the exact methodology you need to unearth maximum marks. Because if you want to move beyond just blindly calculating to actually mastering the exam format, well, you are definitely in the right place. So let's grab our tools and get right into it.
Right off the bat, we have to address a really massive frustration. Why do students consistently lose marks on multi-stage circular measure questions? You know the feeling, right? You memorize the formulas, you do all the practice papers, but then your exam score just doesn't reflect your effort. It's so frustrating. But here's the secret. The issue usually isn't your raw mathematical ability. Actually, it's missing out on those absolutely crucial method marks during your analytical dig. It's all about how you show your process. You see, Cambridge examiners are looking for the journey you took to get the answer, not just the final destination.
So, to fix this, here is our roadmap for today's explainer. First, we'll open up the Circular Measure Toolkit. Second, we'll look at how to unearth those elusive method marks. Third, we'll walk through the ultimate framework: deconstruct, solve, evaluate. And finally, we'll wrap up with the top 3 examiner warnings.
Let's start with Section 1, the Circular Measure Toolkit. This is where we survey our theoretical foundations.
Before any archaeologist starts digging up a site, they have to survey the foundations and gather their primary tools, right? In our case, we have to establish the absolute, non-negotiable theoretical foundations of this topic before we can even attempt a multi-stage exam question. So you have 2 primary tools in your kit. First is arc length, where S equals R times theta. And second is sector area, where A equals 1/2 R squared theta. And the golden rule here? The one thing you cannot forget? Theta absolutely must be measured in radians. Literally, make sure your calculator's in the right mode. These formulas are your bedrock. They appear every single year. But honestly, just knowing these equations is kind of like simply owning a shovel. It's how you use them to dig into the problem that actually gets you the marks.
And that's because the Cambridge syllabus expectation goes way, way beyond simple memorization. They actively expect a connected, conceptual understanding that you can transfer to completely unfamiliar contexts. They're going to throw weird shapes and scenarios at you. So the assessment framework prioritizes analytical depth over just superficial breadth. They really want to see that you understand how, say, a sector area formula interacts with trigonometric identities or coordinate geometry in a completely novel scenario. It's a giant puzzle.
Which leads us perfectly into Section 2, unearthing method marks. Let's talk about the real value of the process.
Okay, if you take away absolutely anything from this explainer, please let it be this. In Cambridge Mathematics 9709, the process of solving is just as vital as the final numeric answer. Examiners actively reward your analytical dig. So, how do we actually extract those method marks from the ground? Well, first, show precise definitions. Don't assume the examiner knows what you're doing. Second, map your causal relationships, meaning show exactly how step A leads to step B. And third, highlight those cross-topic connections. The principal examiner reports explicitly state that candidates who reference cross-topic connections, like seamlessly integrating trigonometry with your circular measure work, achieve significantly higher marks. Your working out is your proof of connected understanding. Please, don't just hide it in your calculator. Put it clearly on the page.
Now for Section 3, deconstruct, solve, evaluate. This is your systematic framework.
Now that we know what the examiners are hunting for, here is the standardized, systematic sequence you need to tackle those complex, multi-stage questions. Think of this as your literal blueprint for the dig site. Step 1, deconstruct the question and extract the data. Don't just immediately start calculating. Take a breath, identify the given information, whether it's hidden in the text or a table, and break the problem into logical layers. Step 2, select your analytical framework and execute. This means grabbing the right tool, like our S equals R theta formula, and solving it systematically with really clear notation. And finally, step 3, verify reasonableness and evaluate. Does your answer actually make sense in the real-world geometry of the problem? If an angle looks obtuse but your math says it's acute, something went wrong. Systematic processing like this is exactly what separates the top-tier candidates from the rest of the pack.
And hey, while you're executing that framework,
You absolutely cannot ignore presentation conventions. The way you visually present your information matters immensely. You've got to use proper headings, correct mathematical terminology, appropriate formats, and clear annotation. Think of this as carefully labeling the priceless artifacts you've just dug up. If the examiner can't follow your sequence, or if your notation is just a sloppy mess, you are going to drop careless marks even if your underlying math is technically spot on.
All right, let's move to Section 4, Top 3 Examiner Warnings. These are the caution signs on our dig site.
Pay close attention here because these are direct, high-stakes caution signs straight from the principal examiners themselves. To protect your hard-earned marks, you have to navigate around these incredibly common traps. Number 1, answers are often way too vague and lack specific details. Number 2, students forget to check their format and presentation, which is exactly what we just talked about. And number 3, which is perhaps the most damaging of all, answers are not specific to the given context. You see, a lot of students treat a geometry problem about, say, a wireframe exactly the same as an abstract circle drawn on a graph. You can't do that. You have to ground your math in the actual reality of the specific question.
Just consider the difference between a generic mathematical response, just floating numbers and abstract formulas, versus a context-specific answer that's firmly linked to the given scenario. The syllabus heavily prioritizes data interpretation skills. You need to extract information from the texts and tables provided, interpret the specific relationships of that exact scenario, and draw evidence-based conclusions. Failing to link your working back to the provided text is a classic, guaranteed way to lose evaluative marks.
And mastering these specifics naturally builds you up to higher-order thinking. At the very highest evaluative levels, top-scoring candidates demonstrate true mastery by doing 3 things. They question assumptions, they consider alternative perspectives or approaches, and ultimately, they justify their decisions with hard evidence. It's really not just about finding x or theta anymore. It's about showing the examiner exactly why your approach to finding theta is the most robust and accurate method for that specific context.
I want to reinforce this with a direct examiner alert. Quote, "The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario." Seriously, read that twice. Burn it into your memory. Whenever you're sitting in that exam hall, imagine this quote flashing like a neon sign in your brain. Your algebraic manipulation might be absolutely flawless, but if it's floating out there in a generic void, you are leaving points on the table. Always link it back. So, as we wrap up our archaeological dig today, I want to leave you with this final, kind of provocative thought. When you finalize your next circular measure answer, is it just going to be a naked number sitting alone at the bottom of the page? Or is it going to be a fully justified, context-specific excavation? Remember your toolkit. Hunt aggressively for those method marks. Stick to the deconstruct, solve, evaluate framework, and whatever you do, avoid those generic answers. Take these strategies, apply them to your very next past paper, and just watch how your marks transform. Thanks so much for joining me on this explainer, and happy studying.